Hello. Can you hear me? Oh, I can hear myself, so I guess you can hear me too.
So, good afternoon. Welcome our next speaker, Vašek Pavlín, and his presentation, How to Make More People on Fast.
Hey, welcome. Welcome to the conference. Welcome to the talk. It's great to have so many people here. Whatever. So we will talk about buses today. So if you like trains, you can go away, or you can stay as well. So there's a major questions in this topic. You have a bus, and each person who rides on it leaves his stuff behind. How do you deal with that? Let me visualize it for you. So you have a bus, and there are people on the bus, and that more people get on that bus. And then people start leaving, and they leave their luggage on that bus. And then you end up with a bus full of luggage where you can't put more people on that. What does that even mean, right? It doesn't make any sense. Well, I'll provide some dictionary. So the bus is OpenShift. People on the bus are the users that you get on the OpenShift, and the stuff are the services that users have there. I'll explain in detail later what are the connections between these things, but mostly in this presentation, it's about Jenkins being run by every user on the OpenShift. And then what left behind means is that the users come, we start some services for them, they leave, and the services keep running, even if they don't use them. So now you know what the presentation will be about. So something about me. I'm Vašek Pavlín, and I worked for Red Hat for the last 5.5 years. For last 4 years, I mostly work with containers. I'm from Brno, from this beautiful city office, and I studied in this building. I like many things, like traveling and stuff. And this is from some music festivals, so I like music as well. So let me start from the beginning, from some basics. So what do we know about containers, or what do we think we know about containers? It's all about OpenShift, right? So you know OpenShift. Who doesn't know anything about OpenShift? Like that it runs containers. So OpenShift runs containers. Okay, good. So containers are tiny. That's a very, very important assumption that most people make, because if you look at all these articles when Docker came around and when we started to hear the hype about containers, we heard that, hey, you can just run this small binary. You build your Golang binary, you put it in a container, and you just run it. It's awesome. Well, containers are just the fancy processes, as Scott McCarthy says. There is a link. I will share the slides later, I guess. So there is a link, but you can find it. Look for fancy process in the Google, and we'll probably find a link. If the process is big, if it consumes a lot of memory and CPU and all the resources, the container will be big. So if the process has a lot of dependencies and you need to install, like with Java, half of the internet or maybe even whole internet, the container will be as big as an internet, right? The second assumption is that containers are fast. They start very fast. They start in milliseconds. If you ever played with containers, you probably saw these demos where you just like build your basic container and you run echo hello world, and it's like it starts in few milliseconds and it's there. It's not like VM starting minutes, right? Well, container is just a fancy process, and if you Google the fancy process, you can go to the article and read what does it mean. Generally, if the process startup is slow, then the container will start for a long time. It will take time to start a container. And the last assumption that I have here is it's cloud. We run our containers in cloud, and it scales endlessly, right? But it's cloud. It has to scale. It's everywhere. Everyone uses that. There's plenty of space. Well, what I heard, I found it also on the internet, there is no cloud. It's just someone else's computer, right? If you think about it, you can have giant data center with many resources, like endless resources, but it will still cost you money, and your money is probably not endless. Well, if it is, you're probably not sitting here. So those are the three assumptions that we have. So it's just a process, and you can't scale endlessly. Potentially you could, but it costs you money anyway, so you can't. If we go, like, we talked about process now, so we go to the basics. What is a process? Process, based on the man page, is machine code instructions running on some data. So we have a piano, which is data, and we have a pianist, which is a process, which is a machine code. If we put them together, it's a process running on some data. What is a container? Container is a restricted process, so you put a pianist in a container, right? And you close it, and he can't escape. He has some limited resources, like air. And in OpenShift and Kubernetes world, there is an abstraction called pod. And pod is like the smallest thing you can operate. And that's 1+ containers, 1 to n containers. That's why we call it orchestration, because you have this orchestra of pianists and a trumpetist, and they play together, and you orchestrate them. So this is like, we have these assumptions running endlessly, all these processes, and they are fast and small, which they are not. So what is the problem again? I've worked on a thing called OpenShift IO. I hope you can see that. And the OpenShift IO is supposed to be, or is going to be, almost it is, integrated development platform. The idea of that is that the workflow for developers and generally teams developing some software is you do project management, you code in your IDE, you run some builds and tests, and you deploy. So we give you some planner where you can plan your work, take work items, assign it to them, assign it to yourself. You can code. You have a web-based IDE called Eclipse Che. You have pipelines, so you can do Jenkins pipelines. You can build your stuff. You can build containers. You can test it. And you have container platform where you can deploy your applications, which is OpenShift Online. And for every single user that we put in this system, we run some services for them. And for every single user, we run Jenkins and we run Eclipse Che. Jenkins is limited, as you saw in the picture, the container, the pianist in the container, is limited to 512 megabytes of RAM. And Eclipse Che is limited. There's two pieces, server and workspace, limited to 600 megabytes and 1.9 gigabytes. If we do some math around that if you imagine that you want to onboard 1,000 users, for Jenkins that have 500 megs, and Eclipse Che, which has 2.4 or 2.5 gigabytes, you get 3 terabytes of RAM for these 1,000 users. And 1,000 users in like service that you want to serve for people and make it generally available for people, that's a lot of RAM, 3 terabytes per 1,000 users. At least I think it's quite a lot. It's a lot. I mean, you don't want to pay for that. So what we can do is we can look at it from the serverless point of view. I had a talk yesterday with my friend Matthias Lubken. We argue about whether containers are better than serverless or serverless is better than containers and what does it solve and doesn't. But I like some perceptions of the world, of the serverless world. And that's basically that if you need to do something, you start a service, it starts very quickly, or you start a function, it starts very quickly, and then when you don't need it, you stop it, right? So this is from Adrian Cockcroft. You can call your path serverless if you can efficiently start services in 20 milliseconds, run it, and stop it. That's what you call serverless. We don't have that, or we can't really use that, because if you want to run Jenkins, Jenkins is Jenkins, it's not serverless, right? But we do have something called idling in OpenShift. So in OpenShift, idling means that you can run a thing, and if there is no network traffic, it stops running. And if there is a network traffic on the route, it gets started again, which is great if you have that Golang binary in your container and it starts in 10 milliseconds. So someone hit the API, it starts, serves, then it's running for some time, and then it dies again. It's very great for these small services. And how it works, it's a concept in OpenShift, just so that you know, there is no API call for idling. It's just magic behind the scenes where you put some annotations on a deployment config and then turn it off and scale it down. I've heard, so it's all based on networking. So if there is no network traffic, it stops. If there is, it starts. I've been talking to people, and I heard that they are looking at using metrics. So you would be able to set up something like, based on these metrics, if these values go below or over some threshold, you can stop this container. That would be great, but it's not that case. So for Eclipse Chat, this works nice, because it's a user-facing application. The user opens a browser, it connects to the server, there is some communication. So when the communication is gone, from browser to server, from browser to workspace, the workspace is turned off. And if there is no communication from workspace to server, the server is turned off. And then when there is a new request, it all starts up again. For Jenkins, it's slightly more complicated. I made these when I start thinking about that, like what everything we need to connect to and read and write and do. I don't want to explain that. So let's make it simpler. So I did 2 iterations. First iteration was like an afternoon project looking at idling in OpenShift, and I wrote a simple Bash script. It's 200 lines. You can find it as Jenkins Dreamer. It's 200 lines, which actually just query the OpenShift API, look for builds in OpenShift, look for the status of the builds, and based on that, either start or keep running Jenkins or stop it. So we have a service that's running in OpenShift in a container that watches builds, and it shoots Jenkins in the head. But it's not, whoa. Shit. That's not enough, right? Because you saw that those diagrams, and it's more complicated than that, because there are users actually trying to access Jenkins. So there are users, and there is, for example, GitHub, because you set up a GitHub webhook request, GitHub webhooks for your Jenkins pipeline or for a Jenkins job. And if GitHub hits your API and Jenkins is not running, there is a 10 seconds timeout. My experience is that Jenkins in container starts approximately in 3 minutes. So you can do the math that 10 seconds and 3 minutes doesn't really match the time span of the timeout. So what I did is that I wrote a proxy in Golang that accepts these requests from users and from GitHub. If it's a GitHub request and Jenkins is not running, it caches the request and replays it later when Jenkins is running. For the user, if the Jenkins is not running, it gives the user very nice loading web page, where he can see that something will take some time, and he can make a coffee or something. Or if the Jenkins is there, it just proxies. And there is also still the watcher, but it's also a Golang application or Golang service now, which watches the builds, watches the proxy, takes some statistics from the proxy, and acts on Jenkins, starts and stops it based on whether there is a traffic, whether there are builds, whether there are cached requests, things like that. So as I already mentioned, it is in Go. It is running on OpenShift. It is talking to various Fabricate services on OpenShift, because OpenShift IO, the upstream stuff, is Fabricate. So it's talking. It's using authentication of Fabricate. So you go to jenkins.openshift.io, and if you are authenticated, you get proxy to Jenkins. If not, then you need to log in. And other things, it figures out the namespaces where Jenkins is running, because OpenShift and Kubernetes are all about namespacing and stuff like that. You can look at the code. It's terrible. I don't like it. But it's undergoing a major refactoring by a gentleman that actually knows Golang, which I didn't before this. If you need to talk to someone about how it's written, now it's Hardy Frenchik. You can talk to him. He will love to bitch about my code. So we have like 4 minutes now, and I think that I've talked enough. You can ask many questions, I'm sure. But the major question now is, where did the bus go, right? Because I was talking about bus, and now I'm talking about some Jenkins stuff. So the bus is safe now. So there is someone who cares about the bus, about OpenShift, and I can like make sure that the luggage doesn't, if people take the luggage away. And that's it. And it was fast. I was going to record some video and show you how like it starts and stops, but as it goes, I had 3 presentations and I like didn't make it. So maybe next time. Any questions? Yes. Does idling work even when you use liveness or readiness probes? I don't understand the question. Right. So what the idling means is that it just scales down the container. It's gone, right? So there is no liveness probes when there is no pod. It scales down the pod, the deployment config. So the pod is gone. And the only thing that is different from normal state is that annotation on deployment config, so that if there is a traffic on the route, and there is no deployment config, but there is no pod, but the deployment config has that idle annotation, it will be started automatically. That's the basics of like how OpenShift idling works. So the liveness probes, they are not active because there is nothing to check if there is no pod. So when you start the container again, from whatever reason, the liveness probes work as normally because they are bound to the pod. Does it answer the question?
Okay, but can they go idle even when the probes will send some requests to the...
Yeah, because the check for the auto idling in v3 is a bit mysterious. Nobody was able to really say whether it works or not. They have some force sleep stuff. If there is anyone from OpenShift and can answer that, please do. I'm not from the OpenShift team directly. I only use OpenShift. But it doesn't work on the pod. So the health checks work on the pod directly. If there is a HTTP request as a health check, it will go directly to the pod IP address. But the idling goes on the higher level, either service or route. So if there is no traffic on service and no traffic on the route, then you can idle the pod, and the health checks doesn't really influence that. Yes? What is the suggestion for scheduled builds? Yeah, this is a very good question. I didn't think about that. It's all broken now. Thank you very much. I think that would have to be taken care of by the watcher thing, the idler, that thing that does these things. So right now it queries the proxy API and OpenShift API for the information when to idle or when to unidle. So it would have to probably query the Jenkins API when it's running and check for the jobs which are timed, and then in the set of conditions that influence idling and unidling, there would have to be like, this is the set of jobs that needs Jenkins unidled. We could potentially also, so this only cares about the jobs that are referenced in OpenShift. So Jenkins pipelines jobs that are synced between OpenShift and Jenkins, right? So if we could do timed jobs as a Jenkins pipeline OpenShift build configs, then it would work by default. If not, then we need to add like another condition and check like, is Jenkins running? Okay, then scrape the timed jobs, store them somewhere in cache, and then act like a timer for that. Yes.
How generic it is being used for all services that Jenkins?
How generic it is. So I was in rush when I was writing that. So word Jenkins is hard-coded all over the place. But generally, like I tried to make it modular so that you can add different conditions. So if we refactor the word Jenkins out of the code, then yes, it's the idling thing is generic. It's just that the use case we have is very specific, but it could be generalized quite easily.
Have you looked into paging into disk and suspending the process? Because it might be like this space way cheaper than RAM.
If we looked into suspending the process to disk, the container to the disk, does OpenShift support that? I don't think so. I don't think it's merged into Docker. I don't think it's in Cryo. I don't think it's anywhere. I think it's just that proof of concept that was done, and then like nobody wanted to touch that ever again. So if that's in OpenShift in any point in the time in the future, then yes, we can definitely do that. But I just want to call some API and say, I don't need that service. Sleep it. Right now, that means scale it down. In the future, it might be suspended to the disk. Jenkins, in OpenShift generally, it has a mounted volume, and that volume, when you're stopping Jenkins, when it gets the terminate signal, it serializes the state to the disk. So when you load it, if you have some builds running, waiting for input or something, it will unserialize it to that state again. So it is not complete, like you would delete your Jenkins configuration and then load it again. It's in somewhere in the middle. But yes, that would be definitely cheaper to just suspend the container. But I don't think that we have that anywhere in the production or even in testing. Any other questions? Doesn't seem so. Okay, thank you very much for attention. If you want to talk to me, I'll be at the party. I'll be here tomorrow, hopefully, if I survive the party. And you can find me on Twitter or send me an email. So have fun. Enjoy the rest of the conference.